Hi everyone. Today we are going to see about the problem LeetCode 1007 minimum domino rotations by equal row. The question is, in a given row of dominoes, top side and bottom side represents the top and bottom of the ith domino. So domino tile is consist of top half and the bottom half. We are given a two vectors which represents the top and bottom halves of all the dominoes in the row. What we need to do is we can rotate the ith domino so that the value of the top side and bottom side may swap, and so we need to find the minimum number of rotations so that the values of the either row tops or bottoms are same. All the values in the tops or bottoms is same. So if it can be done, we need to return -1. Okay. The constraints are the length of the domino row is 2 to the power of 2 into 10 to the power of 4, and the variables which can be present in the row where two vectors tops and bottoms can be 1, 2, 6. Okay. So the first brute force approach will be recursion. We have two options. We can either swap the first tile, we can either rotate the first tile, or we can leave it as it, and we can move to the second tile. In the second tile, we can either swap or leave it as it. So after all the choices we have taken, uh, in the final step, we can check whether uh, all the elements in the either row are equal, and we need to keep track of the uh, number of swaps done. So swaps, the variables will be swaps and the index and the two vectors tops and bottoms. In the when the index I reaches the end of the vector, we need to find the we need to check whether the values in the tops or bottoms, either of them, are equal. So given the constraints, it will throw time limit exceeded at it, as the recursion is a heavy complex process. So we need to take advantage of the top side and bottoms values of top side and bottom side. So it may vary from 1 to 6, 1, 2, 3, 4, 5, 6. 6 These six numbers are the possibilities of the sequence. It's like the value in the tops row can either be 1, 1, 1, 1, 1, or 2, 2, 2, 2, 2, till the last, or 3, 3, 3, till we can do all the six combinations. So what we can try is we can fix one number, optimize to 1. We can fix one number 1, and we will check all the thing in the one. Either we can form one on the top or bottom. So if we fix one here, 2, and in the first tile here is the tops value is 2 and the bottom value is 5, we cannot form one in either of them, so we just return infinity. When we fix 2, we can in the tops row, the number of swaps needed for uh, obtaining the final sequence is 0, because there is already a 2 present in the top side. So we go to the next index. Here we can use one swap and we can get the number 2 at the tops. So the swaps will be 1. We go to the next index and there is already a 2 in the tops, and we don't need to swap, we can move to the next element. We need to swap 1 to bring the 2 up, so +1. So, and here is when we move to the next index, there is already a 2 in the tops, so we don't need to swap, and we just move to the next index. And here is also the same case. So we move to the end of the vectors, and the total, total number of swaps required to make the tops row, all values in the tops row is 2 is 2. Similarly, we just try for all combinations, and we just take minimum of all these results, and it will be the answer. In this example, I have only consider the tops, and we need to check also the bottoms. We need to take 5, we need to take 1, and we need to check the bottoms row as similar to the this example. And the optimized we can also further optimize it by not checking all the combinations 1 2 3 4 5 6. We just need to check whether the uh, first element in the tops first element in the tops and the first element in the bottoms, because to form a valid sequence, these two elements need to be present in the sequence. So like either the two can be this two can be in the tops and all the values will be 2, or the 2 can be swapped to bottom and all the 2 can be 2. Either the 5 can be in the bottom and all the values in the bottoms can be 5. Either we can swap and bring the 5 to the top, and all the values in the top will be 5. We need to find us. We can observe that tops of 0 and bottoms of 0 will definitely be in the sequence of the final resultant. If if a tile doesn't have either of these numbers, we cannot form the required sequence, and we just break it by returning infinity. It is not possible to form the required sequence. Uh, the Okay, let's see the code example. I just create a variable answer equal to 0. Let me create a variable function to calculate the swaps record for forming the required sequence using either of the variable. Let's first fix tops of 0 as the variable of the sequence, and we just check with tops and bottoms. If tops of not equal to bottoms of 0. So this if condition is required because to avoid overlapping uh, function calls, if both values in the top 0 and bottom 0 are same, we don't have to calculate. We need to skip this step because we have already calculated the result here. we create two variables, top swaps and bottom swaps, which keeps track of the number of swaps required to convert the uh, top row as the required series and the bottom row as the required series. If both values of the tops and bottoms in the current index doesn't matches the required value, we cannot form a sequence which consists of equal values. So we just return max. It is not possible to form the required sequence. So here, if the tops of the current index is not equal to the value, we need to swap it to make the top sequence equal to the referred value. So we just increase the number of swaps required to make the top the required sequence. We just add the swap one to the total number of swaps required. And if the bottom's value is not equal to the reference variable, we need to increase the number of swaps required to make the bottom the required series. And we just return the minimum of the total number of swaps required to make the top and the bottom or the bottom. We just need to return the minimum of them. Either we need to make the tops as the required series or we need to make the bottoms as the required series. So to obtain the minimum steps, we just return which is easier to form. It passes all the test cases, sample test cases. We just submit it. Yeah, thank you. For, thank you for watching. And if you have any doubts, let me know in the comment section.